Hello, I'm Robert from Doomsday Debunked, and I'm going to talk about something that people sometimes ask us. They're scared that the moon might hit the Earth or that the Earth might fall into the sun. You don't need to worry about either of those, and I'll just explain a little bit more about it. So first of all, the moon is actually moving outwards, not inwards. It's because of these laser reflectors that the Apollo astronauts left on the moon that we know it so clearly. It's moving at about the speed at which your fingernails grow. So very, very slowly, it's moving very slightly further away. The moon is in an elliptical orbit, so sometimes it's closer and sometimes it's further away. But the whole orbit is shifting outwards just by these this very small amount a year. And that's because way back, originally Earth's day was only 6 hours long. The Earth was spinning 4 times faster, and the moon orbited just 25,000 kilometers away with a month of about 15 hours. And if the moon is orbiting slower, the Earth slower than the Earth is slowing, then it turns out that it raises huge tides on the Earth, and the tides pull the moon forward, which we think might speed it up. Because the strange way gravity works, it actually pushes it outwards. It pulls it forward into a higher orbit, and higher orbit, and the result is that the Earth keeps slowing down because it's pulled backwards by the moon, and the moon keeps pulling forward into higher orbits, and they both slow down. And now we've got 24 hours for the Earth's day instead of 6, and the sort of 15 hours, it's 28, 29, depending how you measure it relative to the sun, days for the lunar orbit. So it's at about the same speed our fingernails grow, 3.8 centimeters a year. The moon is gradually moving out. But so what's going to happen long time? Well, if there was nothing else, just the Earth and the moon, then 50 billion years into the future, then both at around 42 days, the moon would tidally lock with the Earth, and then it would spiral inwards after that, because it's now affected by the sun, which would cause it to, and it would start spiraling inwards towards the Earth. And because now, before, when the Earth was spinning faster than the moon, that pulls the moon outwards. Once it's geostationary, then the moon will start going around faster than the Earth, because we've got a very, very slow day. 1 day is 42 days. And then the moon starts coming inwards and getting faster and faster the more it gets ahead of Earth. And then eventually it gets broken up and turns into a giant ring system like Saturn. And then all those ring particles very slowly would spiral into the Earth. So that is what would happen, except that there are other things going on as well. So the sun is gradually turning into 50 billion years is a long, long time into the future, and if you're looking at on microscale, we change the length of the lunar month just slightly, and we can change the position of the moon by small amounts. For instance, if we were to send an awful lot of material from the moon exported back to the Earth, then that would have depending how it is moved, then it could have no effect on the length of the month, or if you're using something like linear accelerators, it could make a significant change, but still it's only a tiny amount compared to the effect to the lunar orbit. And the same depending how the material is delivered into Earth. If it's via aerobraking, then this can make a difference depending which way you send them. So, and actually, if you just walk in the direction of the rising sun, then you will very slightly increase Earth's rotation rate, but it's not measurable. Then when you stop, its rotation rate will return to what it was before you started walking. Then if you walk away from the rising sun, then you will slightly slow its rotation rate for as long as you're walking, and then as soon as you stop walking, then it will return to what it was before. And so, and then, of course, that's an insignificant amount, but you also have things like trade winds blowing against mountains, and then you have the slow rebound of the ground rising after the ice melted after the last ice age. And all of these things, they make a difference. That is like if you have an ice skater and they put their arms further away, then the spin slows down. So the rebound of the ground rising very slowly can slightly slow down the orbit, the spin of the Earth. So all these things about the spinning of the day length of the Earth, and we've got to the point we can actually measure the effects of these with atomic clocks of some of these things. And what with global warming, and I think global warming should shorten our day by 0.12 milliseconds over the next 2 centuries. And that's because the oceans are getting warmer, and because it's getting warmer, it pushes the surface up very slightly, and that slows down the Earth, just like the spinning ballet dancer putting their arms out. But that's a very, we will be able to measure that, but it's such a minute thing that it's not going to make any difference to your day. It's 0.12 milliseconds shorter in 2 centuries from now. Anyway, so that's not so that's a very minor effect. But what will have an effect is that as the Earth, that in a very far distant future, and we're talking about time so long far in the future that little creatures in the very smallest multicellular creatures that you can find in ponds would evolve all the way to a civilization like ours, assuming that we are typical the time it took us to evolve from the first tiny microscopic creatures. And that could happen dozens of times over, and then the creatures in their ponds could evolve to a civilization, creatures in their ponds could evolve to a civilization, and if we could somehow protect Earth from being too affected, I know, well, the red giant phase, I think is 5 billion years, something like that, 10, 12 times, you'd be able to, you'd have all that evolution would happen before we get there. So it's really so far into the future that you don't really need to worry about what's going to be happening in then. But over those vast time scales, then if the Earth Moon system orbits inside the outer shell of the red giant, then the Moon will spin in quite rapidly, and so much sooner than the 50 billion years it would be otherwise. And then the ring system, would be stripped out by the solar wind. But to avoid that, then the Earth would need to be 15% further away from the Sun than it is now. And if it was 15% further away, then it wouldn't be enough inside the extended atmosphere for the Moon to spiral in so soon. So, but if you look at all those dozen or so different technological civilizations that could evolve all the way from scratch, and then if you look at ours, imagine ours going on for billions of years over all that time scale, in one way or another, and probably lots of different creatures join into it. I mean, I think in our future, there's a lot of the creatures that we have that have become there. I think human beings are probably having an effect, making other creatures on the planet more intelligent. We're setting them endless puzzles. The birds trying to deal with the complex technology, not just the things we do with our experiments, but just them having to take part in find a way, like for instance learning to cross a road safely. That's a very unusual situation, or being able to find things in dustbins and so on. And I think over millions of years, then we're going to have intelligent foxes and intelligent crows and parrots and things that will be able to speak and take part in our civilization like we do. That's very speculative, but I think it wasn't so long ago that we had several hominids that all had some degree of civilization, some degree of being able to speak and do things. The Hobbit man was the Hobbit people. That was so only that wasn't so long ago. Then you have Neanderthal man and the Denisovan man and so on. So these there was a time not so long ago when there were at least several different species of hominids, and I expect the usual situation on most planets with intelligent life will be different species, maybe even the giants. And for all we know, there might be the giant squids at the bottom of the ocean. We know very little about them, and they must have big brains, and octopuses are pretty intelligent. Could they possibly have some kind of intelligence not far off ours? Nobody's ever even seen them for very long, because they die as soon as they come to the surface. Anyway, over these vast timescales with all these different, whatever species take part in our civilization, then we've got all this time in which we could actually move the Earth. And we can do it in many ways. We know how to do it now. If we had if we put a massive effort into it, and we had extremely reliable technology, then what you would get is you get a very big comet or an asteroid, and you would put it in an orbit where it goes around Jupiter, and it goes around Earth. It goes back and forth between the two. And if you choose the right orbit, you can use that to transfer some of the momentum of Jupiter to Earth in order to shift Earth outwards, just by doing the flybys. And it would be possible over billions of years, and sending this thing back and forth, but it's got to be supremely reliable, because it's sending a huge big comet or huge asteroid with repeated flybys of Earth. And obviously you want to be absolutely sure that every time it's going to just miss by just the right amount to, you want to be as close as possible to Earth, get as much effect as you can, and yet miss it every time. We are not at the level where our technology is up to doing stuff like that reliably and safely, even if we were to put huge amount of money into it. We would have to be very confident that our civilization is going to last. I think maybe, but if our civilization may well be still here a million years from now, and think how reliable our technology is likely to be when we've been, and maybe by then people are living for thousands of years, and they expect things to be far more reliable by then. So in the future, maybe we will have the technology and maybe different kinds of fusion power and things where we can actually move the Earth further out in order to, if we want to. And so, anyway, so that's another thing that can happen, is and we can spin the Earth up and slow it down. And I think we really don't need to worry about these very long time scales. Leave the Earth in good state at the end of our generation. Those future millions and millions of generations into the future, then as long as we pass them on with a good world, but at the end of our generation, then they will face their problems as they come to them, and they will have to find their solutions. It's not very likely that we can do too much at the present that will actually be beneficial for them directly for whatever they want to do, because it's so hard to anticipate. We make mistakes even trying to predict what our planet's going to be like 10 years from now in terms of technology, 50 years from now. Nobody really predicted the mobile phone. And nobody predicted Skype. That we would be able to have little computers and talk to each other via Skype. Nobody in advance of that really saw it happening, not quite like that. So anyway, now there's this possibility that Mercury, now this is very distant future, billion years from now, it's only a 1% probability in most cases. If it gets disturbed, it hits Venus or Earth, and Earth is Venus and Earth is unaffected. But out of 2,501 cases, one of them led to complete destabilization within the solar system inside Jupiter, and then in that destabilization, then there were 5 of them in which Mercury hits Earth, out of 201 out of 2,501. So now this is not going to happen for billions and billions of years, but there's a tiny fraction of a % possibility that Mercury eventually hits Earth. That's about 3 to 4 billion years into the future. And they didn't study it hitting the moon, but there must be a minute chance of it hitting the moon as well. So if Mercury hits the moon, then anything could happen. It could shove the moon out it could shove the moon out and it could go roaming around the solar system and eventually hit the sun, or eventually fly past Jupiter and hit Jupiter, or be ejected from the solar system. Um, and and one of the possibilities would be that the moon could hit Earth. So that would be that's the only way I know of that the moon could directly collide with Earth, rather than spiral inwards and turn into a ring system. And but I mean, there wouldn't be much of a moon left after being hit by Mercury anyway. And I think that's rather an academic's answer to this. So and you don't need to worry about rogue planets. That's just so you're talking about hundreds of trillions of years for that sort of thing. So that's so academically it's possible, but I mean, if you think about all the civilizations that will be on Earth before this time, 3 to 4 billion years from now, it's only a 1% probability. We could already move Mercury just as we could move Earth if we had a huge amount of effort into it. So they could keep Mercury's orbit stable if they really had to in that very distant future, assuming they still have technology. And so I don't think we need to worry about any of this. So there we are. We've got the moon. It's theoretically, yes, the moon and Earth can collide. Most likely, very distant future, it's into a ring system. It could only really collide Earth if it was hit by Mercury, which is very, forget about that, because that's 3 to 4 billion years and all the possibility of doing something about it in that very remote chance. So now I'm going to look at why doesn't the Earth fall into the Sun, and why doesn't the moon fall into Earth? I get lots of people worrying about that. I'll do that as a separate video, so as to keep these short.